Tonight, we are going to ask the strangest version of the oldest question a human being can ask. Are you the only one of you? For most of human history, the question would have sounded almost silly. Of course, you are the only you. Your body sits in this particular room, in this particular country, on this particular planet, at this particular moment. There is no other you. There has never been another you. The world is full of other people, similar in many ways and different in many others, but none of them are you. But over the past century, physics has been quietly building a different answer. Not one alternative, 5. Tonight we're going to walk through 5 separate ways in which modern physics suggests that there are other versions of you somewhere in the cosmos, or in the structure that contains the cosmos, or in the mathematics that contains all of physical reality. 5 different multiverses, each one constructed from different physical or philosophical principles, each one ending with the same uncomfortable implication. You are not the only one, you are one of many. The many may be infinite. Before we get started, sit with how this question feels, because the feeling is part of the story. The first reaction to learning about multiverse cosmology is, for most people, one of disorientation. The intuition that you're unique is so deep that the alternative is hard to take seriously. The mathematics, however, does not care about your intuition. The mathematics points in a particular direction, and the direction is uncomfortable, and the discomfort is itself information about how much of your worldview is built on the assumption of singular existence. Slowly we walk into the 5 multiverses one at a time. We will move gently. We will move at the pace of sleep. The story does not need to be finished tonight. It will be here whenever you come back to it. The 5 multiverses are these. The first multiverse is the volume multiverse. It is the simplest of the 5, and it depends on only one assumption. If space extends infinitely in every direction, then all possible arrangements of matter must appear somewhere, including arrangements that exactly match the configuration of atoms inside your body right now. Identical copies of you exist somewhere in the infinite cosmos by combinatorial necessity. The volume multiverse is the mathematical consequence of a simple cosmic geometry. The second multiverse is the bubble multiverse. It emerges from the theory of cosmic inflation, particularly the framework called eternal inflation developed by Andre Linde. In this picture, our entire observable cosmos is one bubble in an enormous inflating background. Other bubbles exist, separated from us by vast inflating regions. Some of them have different physical constants. Some of them are similar to ours but slightly different. Among the bubbles whose physics resembles ours, some will contain copies of you. The bubble multiverse is the consequence of taking inflation seriously to its end. The third multiverse is the quantum multiverse. It comes from the many worlds interpretation of quantum mechanics, originally proposed by Hugh Everett in 1957. Every time a quantum measurement happens, the universe branches into all possible outcomes. Across the branching tree of cosmic history, every possible version of every quantum event has occurred. Every possible version of you exists on some branch. The quantum multiverse is the consequence of taking quantum mechanics literally. The fourth multiverse is the mathematical multiverse. It is the most abstract of the 5. Proposed by Max Tegmark, the framework suggests that all mathematically consistent structures exist as physical realities. Our universe is one such structure. Other structures, including ones containing variants of you, also exist. The mathematical multiverse is the consequence of taking the mathematical foundations of physics with maximum philosophical seriousness. The fifth multiverse is the simulated multiverse. It comes from the simulation argument proposed by Nick Bostrom in 2003. The argument suggests that if civilizations capable of running highly detailed simulations of cosmic history are likely to ever exist, then we are almost certainly in a simulation rather than at the base level of reality. Any sufficiently advanced civilization would run vast numbers of simulations. Most conscious observers in this picture are simulated. You are likely to be one of them. Many other versions of you, in many other simulations also exist. 5 multiverses, 5 sets of copies of you, 5 different reasons to take seriously the idea that the singular life you are living is not as singular as it appears. By the end of tonight, you're going to understand each of the 5 frameworks in some detail. We will look at where each one comes from, what assumptions it depends on, what evidence supports it, and what implications it has for your sense of singular existence. Some of the frameworks are mainstream physics. Others are philosophical extensions of mainstream physics. None of them are crackpot. All of them are taken seriously by significant fractions of the physics or philosophy community. Pattern interrupt. The feeling that you are unique is intuition. The arguments we're about to walk through are physics and mathematics. The two are not always aligned. The point of tonight is not to convince you that the intuition is wrong, but to walk slowly through the reasoning that has, over the past 60 years, led increasing numbers of serious thinkers to question whether the intuition tracks reality. No one expects, on first hearing about the multiverse, that the same conclusion would emerge from 5 independent lines of reasoning. No one predicts that the question of whether other yous exist would have not one answer but a hierarchy of answers, each layered on top of the last. Absolutely no one anticipates the way each successive multiverse contains the previous ones as special cases, building up to a picture in which the cosmic count of views is, in the strongest possible sense, infinite. Now let's begin with the first multiverse, the volume multiverse. The first multiverse depends on a single observational fact and a single mathematical consequence. The fact is that the cosmos appears, as far as our most precise measurements can determine, to be spatially flat. The consequence is that, if the cosmos is flat and infinite, then identical configurations of matter must repeat across the infinite space. Take a moment to sit with the basic argument, because it is in many ways the simplest of the 5 multiverses to state, and the hardest to dismiss. The reasoning goes like this. A finite volume of space can contain only a finite number of possible arrangements of matter. The arrangements depend on the positions, energies, and quantum states of the particles within the volume. The number of distinguishable arrangements is large but finite. For a volume the size of the observable universe, the number is finite, though it is enormous, on the order of 10 to the 10 to the 122nd power. That number is so large that no human intuition can grasp it. It is a 1 followed by a quantity of zeros that is itself a quantity of zeros that no piece of paper could ever hold. But it is still finite, and in an infinite cosmos, every finite arrangement of matter must, by simple combinatorial argument, occur not once, but infinitely many times. If you wait long enough, or walk far enough, you will eventually encounter an arrangement of matter identical to the configuration in your body right now. The relevant distance, calculated by Max Tegmark and his collaborators, is approximately 10 to the 10 to the 128 meters. The distance is so far beyond any practical measurement that we will never observe it. But the mathematics is unambiguous. In an infinite spatially flat cosmos, identical copies of you exist, separated from you by distances so vast that they may as well be in separate universes, but located in the same physical cosmos that you currently inhabit. By the end of tonight, you're going to understand that the volume multiverse is not a speculative extension of physics. It is a straightforward consequence of the basic assumption that the cosmos is infinite, which is in turn the simplest and most natural extension of the observations we have. The cosmos is observed to be flat. The flat cosmos, in the simplest model, extends without limit. The unlimited cosmos contains repeating arrangements. The repeating arrangements include identical copies of you. Pattern interrupt. The identical copies are not approximations. They are exact atom-for-atom matches. Every neuron in their brains is in the same state as every neuron in yours. Their memories are the same as yours. Their thoughts at this exact moment are the same as your thoughts at this exact moment. They are not similar to you. They are you, in a sense more rigorous than ordinary intuition can encompass. They are reading these exact words, in identical rooms with identical feelings, at this identical moment. Slowly, we sit with the strangeness of this. You are not just one, you are many. The many are not approximations or analogues. They are exact duplicates, existing in real physical space, separated by distances so enormous that you will never meet them, or know them, or have any causal contact with them, but existing nonetheless. The volume multiverse asserts that you exist as a multitude, distributed across an infinite cosmos, with each copy of you living a life identical to yours up to this moment. Beyond the identical copies, the volume multiverse contains near copies as well. There are copies of you that differ from you in small ways, copies who made one slightly different decision in the past, copies who took a different job, copies who married a different person, copies who never met the people you love, copies who became wildly successful at the thing you tried and failed at, copies who tried something you never tried and succeeded beautifully. The full population of near copies in the volume multiverse covers every possible variation on your life, with the variations distributed across a population that is, in the strict mathematical sense, infinite. The first multiverse is therefore not just a multiverse of identical yous, it is a multiverse of every possible version of you, each one living out a life that branches from yours at some specific moment, or that has been different from yours throughout. The volume contains all of them. The volume in the simplest cosmology extends to infinity. Absolutely no one anticipates that the simplest cosmic geometry, the spatially flat infinite cosmos, has this implication. The standard story is that the cosmos is large, but the question of other use is a separate one, requiring special multiverse physics. The truth is that infinite space alone is enough. Once the cosmos extends without limit, the volume multiverse follows by counting alone. Walk with me through one more layer of strangeness. The volume multiverse does not require any exotic physics. It does not require new particles. It does not require modifications to general relativity. It does not require quantum mechanics to be interpreted in any particular way. It requires only that the cosmos extend forever, and the cosmos is observed to be flat in a way that is consistent with infinite extent. The volume multiverse is, in this sense, the most conservative of the 5 frameworks. It depends on the fewest assumptions. It generates the most direct implications. Tonight, we're going to spend a more careful pass on the mathematics behind the volume multiverse, because the calculation that produces the famous distance to your nearest identical copy is one of the most elegant in modern cosmology, and the calculation is worth doing slowly. The calculation was first done in detail by Max Tegmark in 2003 in a paper titled Parallel Universes that has become one of the most widely cited works on multiverse cosmology. Tegmark was working out, with careful attention to what the standard model of cosmology actually implies, the consequences of the assumption that the cosmos is spatially flat and infinite. The basic logical structure of the calculation runs as follows. A volume of space the size of our observable universe contains a finite amount of matter, organized into a finite number of distinguishable arrangements. By distinguishable, we mean arrangements that differ by at least the resolution of the laws of physics that govern them, which in quantum mechanics is set by the Planck scale. The number of distinguishable arrangements of matter in a volume the size of the observable universe is enormous but finite. Tegmark estimated the number by counting the number of quantum states available to the matter in our observable cosmos. The matter consists of, in round numbers, 10 to the 80th particles, each one capable of being in a finite number of quantum states. The total number of distinguishable arrangements of all the matter in our observable universe is bounded above by 10 to the 10 to the 122nd power. The number is a 1 followed by 10 to the 122nd zeros. No one expects, on first encountering this number, that any quantity could be that large while still being finite. No one predicts that a careful count of the possible configurations of matter in the observable universe would produce a result so far beyond the reach of normal arithmetic that it has to be written with stacked exponents. Absolutely no one anticipates the way the simple operation of counting quantum states ends up generating quantities that, while bounded, are bounded by limits we cannot meaningfully picture. In an infinite cosmos, every possible arrangement of matter occurs not once, but infinitely many times. The relevant question is how far you have to travel on average to find an arrangement of matter identical to the arrangement in any given volume the size of our observable universe. The answer depends on how the matter is distributed across the infinite cosmos. Assuming that the distribution is, on the larger scales, statistically uniform, the average distance to the nearest identical copy is approximately 10 to the 10 to the 128th meters. Slowly we sit with this distance. It is not a distance you can meaningfully compare to anything. A light year is about 10 to the 16th meters. The diameter of the observable universe is about 10 to the 27th meters. The distance to the nearest identical copy of our observable universe is 10 to the 10 to the 128th meters, which is roughly 10 to the 10 to the 101 billion light years. The number is not just astronomically large, it is logically large in a way that almost no other number in physics is. Pattern interrupt. The identical copy at that distance does not just contain a copy of our cosmos. It contains a copy of your room, your body, your brain, your thoughts at this exact moment, all configured identically to the configuration in your current location. The mathematics is unambiguous. In an infinite flat cosmos, identical copies of you exist at calculable distances. The calculation is precise. The distances are enormous but finite. The volume multiverse also produces at much shorter distances copies of you that differ from you in small ways. The average distance to the nearest copy of you that differs in only one small way, say a copy who made one slightly different decision in the past, is much shorter than the distance to the nearest identical copy. Tegmark's calculations suggest that, in an infinite cosmos, the nearest copy of you who is recognizably you, but has made some small different choice, is perhaps 10 to the 10 to the 100th meters away. The number is still beyond ordinary comprehension, but it is much smaller than the distance to an identical copy. The full population of near copies, copies with various degrees of difference from you, fills the infinite cosmos at various average distances depending on how different they are. Copies that differ from you in trivial ways are at relatively closer distances. Copies that differ from you in major ways are at greater distances. The full multiverse of versions of you in the volume picture is a continuous spectrum from identical to almost unrelated, filling the infinite cosmos at all distances. By the end of tonight, you're going to understand that the volume multiverse is not a single multiverse with discrete copies. It is a continuum. Every conceivable variant of you exists somewhere in the infinite cosmos, with the distribution of variants determined by how different they are from your particular configuration. The identical copies are rare and far away. The near copies are more common and closer. The very different copies are also distributed throughout. All of them are there. Absolutely no one anticipates that a simple infinite cosmos would have this implication. The standard story is that the universe contains many people who are similar to each other in various ways. The truth is that if the cosmos is infinite, the universe contains literally every conceivable version of every conceivable person, distributed at calculable distances. The combinatorics is what produces the conclusion. The combinatorics is what makes the conclusion unavoidable once the infinite extent is granted. Take a slow breath here. The distance numbers are real, in the sense that they follow from explicit calculations. The conclusions about other U's are also real, in the same sense. The conclusion that other U's are unreachable is also real. The mathematics produces both the existence of the copies and the impossibility of any contact with them. The cosmos in the volume multiverse picture is generous with its production of versions of you and stingy with its provision of any means to meet them. This is one of the most disquieting features of the volume multiverse. No one expects this, but the cosmic count works out that way. The other U's are guaranteed to exist by the mathematics, and they are guaranteed to be unreachable by the same mathematics. No one predicts this, and yet it follows from the basic premises. The framework gives, with one hand, the comforting thought that all your alternative selves are out there living their alternative lives. It takes away, with the other hand, any possibility of confirming or contacting them. You will never know what they are doing. They will never know what you are doing. No one predicts this, and yet it follows from the basic premises. The cosmic ensemble exists, but it exists in isolation. The first multiverse is the volume multiverse. Its copies of you are not metaphorical. They are physical. They exist in the same cosmos that contains you. They are unreachable by any conceivable instrument, separated by distances that exceed the reach of any future telescope or signal. But they are there, by the simplest argument from combinatorics applied to infinite space. The second multiverse is the bubble multiverse. It is one level more speculative than the first, and it depends on a specific theoretical framework that has become the standard picture for the very early universe. Tonight we're going to walk through this carefully, because the bubble multiverse is the most physically motivated of the multiverse frameworks, beyond the simple infinite volume picture. It comes directly from the theory of cosmic inflation, which was developed in the early 1980s and has since become a standard component of modern cosmology. The basic story is this. In the very early universe, perhaps within 10 to the minus 35 seconds of the Big Bang, the cosmos underwent a brief period of exponential expansion driven by a field called the inflating. The expansion stretched a microscopic region of hot, dense plasma into the size of, at minimum, our entire observable universe. The mechanism solved several outstanding problems with the standard Big Bang model, including the horizon problem and the flatness problem. By the late 1980s, inflation had become a widely accepted component of cosmological theory. But inflation, in most well-developed models, does not end everywhere at the same time. The inflating field decays in some regions earlier than others, producing pockets of normal post-inflationary cosmos surrounded by regions that continue to inflate. The framework, developed in detail by Andre Linde in the late 1980s, is called eternal inflation. In the eternal inflation picture, the cosmos is, at the larger scales, perpetually inflating, with isolated bubble universes nucleating within the inflating background. Each bubble is a universe in its own right, with its own internal history, its own observers, its own physical content. Quietly, we trace what this implies. Our own observable universe is, in the eternal inflation picture, one bubble among many. There is no center to the inflating cosmos. There is no edge. There is just an ongoing process of nucleation and inflation, producing bubble universes faster than the existing bubbles can occupy the inflating space. The total number of bubbles integrated across infinite cosmic time is unbounded. The number of bubbles in existence at any moment, depending on the details of the model, ranges from very large to infinite. The bubbles are not necessarily identical. Different bubbles can, in many inflationary models, end up with different physical constants. The strength of gravity, the masses of fundamental particles, the value of the cosmological constant, the structure of the electromagnetic interaction, all of these can vary across bubbles. In string theory, the variation is particularly rich. The string theory landscape, as it is called, may contain 10 to the 500th distinct stable configurations for the laws of physics, each one corresponding to a possible kind of bubble universe. Pattern interrupt. The 500 exponent is not a typo. Different versions of string theory predict different size landscapes, but the larger estimates run to 10 to the 500th power or more. The number of possible bubble universes, each with its own laws of physics, is so large that listing them would take longer than the cosmos has existed, even if you could list one per Planck time. Most of the bubbles in this landscape are not friendly to life. They have physical constants that make atoms unstable, or that prevent stars from forming, or that produce a cosmic expansion too rapid for any structure to assemble. The bubbles that resemble ours, with constants tuned to allow stable atoms, stars, planets, and biology, are a small fraction of the total. But because the total is unbounded, the fraction friendly to life is still, in absolute terms, enormous. The number of bubbles with physics similar to ours is, in most calculations, infinite. Among the bubbles with physics similar to ours, some will contain galaxies, stars, planets, and life broadly similar to what we observe. Some will contain copies of you. The copies will not be identical to you in the strictest sense, because they will be embedded in bubbles whose detailed cosmic history is different from ours. But they will be similar enough to count as recognizable versions. They will have your face, your memories, your thoughts at this moment. They will be reading these words, in their version of these words, in their version of this moment. By the end of tonight, you're going to understand that the bubble multiverse contains not just copies of you, but variants of you, adapted to slightly different physical conditions. A version of you in a bubble where gravity is slightly weaker would weigh less. A version of you in a bubble where the electromagnetic interaction is slightly stronger would have differently configured biochemistry, though still recognizably you. A version of you in a bubble where the early cosmic history was slightly different might be in a different country, or a different decade, or have different parents. The bubble multiverse provides not just identical copies, like the volume multiverse, but a richer ensemble of recognizable variants. Walk with me through the experimental status of the bubble multiverse. Eternal inflation is, in some sense, the most natural consequence of the inflationary models that fit our cosmic observations. The models that produce a single observable universe and stop are, in most cases, more contrived than the models that produce eternal inflation. The eternal inflation framework is therefore taken seriously by significant fractions of the cosmology community. The skepticism, when it exists, is not about whether inflation happened. The evidence for some kind of inflationary epoch is strong. The skepticism is about whether the eternal inflation framework correctly extrapolates the basic inflationary picture. Some theorists, including Paul Steinhardt, one of the original architects of inflation, have argued that eternal inflation has problems that make it less natural than its proponents claim. The debate is active. The framework remains a leading candidate for what the very early universe was doing, but it is not unchallenged. The direct experimental evidence for other bubbles beyond our own is essentially zero. The other bubbles, separated from us by inflating regions that expand faster than light, are causally disconnected from our cosmic horizon. We cannot send signals to them, they cannot send signals to us. Their existence is inferred from theoretical reasoning, not from direct observation. Whether this counts as evidence for their existence depends on how seriously you take theoretical reasoning as a guide to reality. Some researchers, including Stephen Feeney and his collaborators, have searched for indirect evidence of bubble collisions in the cosmic microwave background. If our bubble had, at some point in cosmic history, collided with another bubble, the collision might have left a faint imprint on the CMB. Searches for such imprints have produced null results. No bubble collision signatures have been detected. The absence of detection is consistent with several possibilities, including that no collisions have occurred, that collisions occurred but left no measurable signature, or that the eternal inflation framework is incorrect. The data suggests that the bubble multiverse is therefore in a particular epistemic state. It is theoretically well motivated. It is empirically untested. It is consistent with all current observations. It is not, by any strict criterion, confirmed. It is taken seriously by the community as a candidate framework, but it is not regarded as established science in the way that, for example, the existence of dark matter or the accelerating cosmic expansion are established. What this means is that the second multiverse, the bubble multiverse, sits in a middle epistemic zone. It is more speculative than the volume multiverse, which depends only on the simple geometric assumption of infinite flat space. It is less speculative than the mathematical multiverse, which we will reach later tonight. The bubble multiverse is in some sense the most representative of the multiverse frameworks. It is what most working cosmologists mean when they refer to the multiverse without qualification. Before we walk into the third multiverse, take a slow breath here. 2 of the 5 multiverses are now in front of us. The volume multiverse, in which infinite flat space contains identical copies of you by combinatorial necessity. The bubble multiverse, in which eternal inflation produces a vast ensemble of bubble universes, some of which contain variants of you adapted to similar physical conditions. Both frameworks generate, in the limit, infinite versions of you. The first does it through simple geometry. The second does it through inflationary cosmology. Tonight, we're going to walk through the string theory landscape in more detail, because the landscape is where the bubble multiverse picture gets its most dramatic predictions, and the predictions are worth examining carefully. String theory was developed, in its modern form, beginning in the late 1960s as an attempt to reconcile quantum mechanics with general relativity. The basic idea is that the fundamental constituents of matter are not point particles but tiny vibrating strings, perhaps 100 billion times smaller than a proton. The vibrational modes of the strings correspond to the various particles observed in nature. Different vibration patterns produce different particles. The framework provides, at least in principle, a unified description of all 4 fundamental forces. String theory has, however, encountered a persistent problem. The mathematical framework is consistent only in higher dimensional spacetimes, typically 10 or 11 dimensions rather than the 4 we observe. To produce the 4-dimensional world we live in, the extra dimensions must be curled up into compact shapes too small to detect. The specific shape of the curled dimensions determines the physical constants and laws of the 4-dimensional universe that emerges. Different shapes produce different physics. The problem is that the number of consistent shapes for the curled dimensions is enormous. By the early 2000s, work by Busso, Polchinski, Susskind, and others had established that the number of stable configurations, called vacua of the string theory landscape, is at least 10 to the 500th, and possibly much larger. Each vacuum corresponds to a possible universe with a possible set of physical constants. The number of possible universes is, in this picture, far larger than the number of particles in our observable cosmos. By the end of tonight, you're going to understand why this matters for the bubble multiverse. In the eternal inflation framework, the inflating cosmos can settle into any of the vacua of the string theory landscape. Different bubble universes nucleating in the inflating background can settle into different vacua. Each bubble therefore has its own physical constants, drawn from the enormous string theory landscape. The full ensemble of bubbles populates the landscape. Pattern interrupt. No one predicts the consequence, but it is real. The implications are striking. Among the 10 to the 500th possible vacua, only a tiny fraction produce universes with physical constants compatible with the formation of stable atoms, stars, and biological complexity. Most vacua produce universes that are sterile in fundamental ways. The strength of gravity might be wrong. The masses of fundamental particles might be wrong. The cosmological constant might be too large to permit any structure to form. The string theory landscape as a whole contains a vast wasteland of dead vacua. The narrow strip of vacua compatible with life is a small fraction of the total. Quietly we observe that this picture has an immediate implication for the question of why our universe has the physical constants it has. The cosmological constant in our universe has a value about 120 orders of magnitude smaller than the natural value predicted by quantum field theory. This is one of the most striking fine-tunings in all of physics. The string theory landscape combined with the bubble multiverse provides a possible explanation. Most bubbles in the landscape have larger cosmological constants and produce universes that are too quickly torn apart by accelerating expansion to permit any structure to form. Observers can only exist in the small fraction of bubbles with cosmological constants close to ours. We are in one of those bubbles. The fine-tuning is selection bias. Absolutely no one anticipates, on first encountering the cosmological constant problem, that the solution might involve invoking 10 to the 500th alternative universes. Absolutely no one anticipates that the most successful explanation for one of the most precise measurements in physics would turn out to be a multiverse hypothesis combined with anthropic selection. Absolutely no one anticipates the way the bubble multiverse, which began as a speculative extension of inflation, has become a candidate explanation for some of the most stubborn puzzles in fundamental physics. The position of André Linde, one of the original architects of eternal inflation, on these matters has been consistent. Linde has argued for decades that the multiverse is not only a real consequence of inflation, but also a productive framework for thinking about the foundational questions of cosmology. Other prominent advocates include Steven Weinberg, who used multiverse reasoning to predict the value of the cosmological constant before it was measured, and Leonard Susskind, who has argued that the string theory landscape combined with the multiverse provides the best available explanation for the structure of our specific universe. The opponents are equally distinguished. Paul Steinhardt, also an architect of inflation, has argued that the multiverse undermines the predictive power of cosmology and should be rejected. Other critics, including various philosophers of science, have argued that multiverse hypotheses cross the line from empirical science to metaphysical speculation, since they cannot be tested by observations of other bubbles. The data suggest that the resolution of this debate may come, eventually, from a combination of theoretical and observational developments. If string theory itself can be more directly confirmed through observations of the early universe, or through experiments at higher energies than the Large Hadron Collider, the case for the landscape interpretation strengthens. If the landscape can be shown to actually predict the values of the physical constants we measure, rather than just being consistent with them, the case strengthens further. If neither of these happens over the coming decades, the multiverse may remain a theoretical proposal without observational support. Walk with me through one more aspect of the bubble multiverse that has practical implications for the count of versions of you. Within the subset of bubbles with physical constants similar to ours, the cosmic histories can still vary substantially. Different bubbles may have different initial conditions, different distributions of galaxies, different cosmic events. The variants of you in these bubbles are similar to you but not identical. They live in cosmoses that look like ours at the largest scales but differ in detail. Among these similar bubbles, some will contain Earths with histories similar to ours. Among those, some will contain people similar to you. Among those, some will contain people whose biographies match yours up to small variations. The fraction is, in any given calculation, small. The total count, summed across the infinite or near infinite number of bubbles, is still enormous. The bubble multiverse, in this sense, generates a vast population of U variants in a richer structure than the volume multiverse alone provides. By the end of tonight, you're going to understand that the bubble multiverse, combined with the string theory landscape, is the most physically detailed of the multiverse frameworks. It depends on specific theoretical frameworks, particularly inflation and string theory, that have been developed for independent reasons. It produces specific predictions about the distribution of physical constants across bubbles, and some of those predictions have been used to anticipate measured values, like the cosmological constant. It also predicts vast numbers of unreachable bubble universes, including ones containing copies and variants of you. Before we continue, why this channel exists. If you have made it this far into a story about cosmic versions of yourself, you're not the casual viewer the platform expects, you're the person for whom this channel was made. Long-form cosmology, at the pace of sleep, with the time to develop a question across multiple chapters and not collapse it into a 5-minute summary, is not what the algorithm rewards. It is what we make anyway, because we believe that the universe taken slowly is more interesting than the universe taken fast. If that resonates with you, the simplest gift you can give the channel is to subscribe. Subscribing tells the platform that long, calm cosmic work is worth surfacing for the next person who needs a quieter way to think about reality. If you have already subscribed, thank you. Truly. If this is your first long-form cosmic night with the channel, welcome. The queue contains many more nights like this one. A small additional note. If Spotify is where you find yourself during sleepless hours, consider following the show there as well. The audio versions are tuned for the same purpose, the same pace, the same length. We want to be a slow companion across both surfaces, whichever one finds you when you need it most. Now, let us return to the cosmos. The third multiverse is waiting. It is the strangest of the 5. The third multiverse is the quantum multiverse, and it is the one that will probably feel the strangest when you sit with it carefully. It is also the one with the most direct connection to a physical theory that has been experimentally tested to extraordinary precision over the past century. Tonight, we're going to walk into this slowly, because the quantum multiverse, often called the many worlds interpretation of quantum mechanics, is the source of more philosophical anxiety than perhaps any other idea in modern physics. It has been embraced by some of the most respected physicists alive today, and dismissed by others as unverifiable speculation. The debate has been going on for almost 70 years and shows no sign of resolution. The basic story begins with the strange behavior of quantum systems. When a quantum measurement is made, the system being measured is, before the measurement, typically in a superposition of multiple possible states. An electron passing through a double-slit experiment is, in some sense, going through both slits at once. A photon emitted by an atom is, in some sense, emitted in all possible directions at once. A nucleus undergoing radioactive decay is, in some sense, both decayed and not decayed at the same time until measured. When a measurement is made, the superposition appears to collapse to a single outcome. The electron is detected at one specific position. The photon is detected by one specific receiver. The nucleus is found to be either decayed or not decayed. The other possibilities, present in the superposition before measurement, seem to disappear. This is the so-called measurement problem of quantum mechanics. The collapse process, called wave function collapse, has been a source of philosophical difficulty since the foundations of quantum mechanics were laid down in the 1920s. The standard textbook interpretation, sometimes called the Copenhagen interpretation, treats wave function collapse as a basic feature of nature, with the act of measurement somehow producing a definite outcome from an indefinite quantum state. The interpretation works in practice but raises deep questions about what counts as a measurement, why measurements produce definite outcomes, and what happens to the other possibilities present in the pre-measurement superposition. In 1957, a young physicist named Hugh Everett, working on his Princeton doctoral thesis under John Wheeler, proposed a radical alternative. What if there is no collapse? What if all the possibilities in the quantum superposition continue to exist, with each measurement causing the universe to branch into multiple versions, one for each possible outcome? Take a moment to sit with this. In the Everett picture, when you measure an electron's position and find it at a particular location, the version of you that detected the electron at that location is one of many. Other versions of you, in parallel branches of cosmic history, detected the electron at the other possible locations. The branches do not interact. They cannot exchange information. They are causally disconnected from each other. But all of them are equally real, and all of them contain a version of you who has just performed the measurement. The Everett interpretation eliminates the measurement problem by eliminating the collapse process. There is no special quantum process called measurement. There are just unitary quantum interactions in which the quantum state evolves smoothly according to the Schrödinger equation, producing entanglement between the system being measured, the measuring device, and the observer. The smooth evolution produces in the end multiple branches of a cosmic history, each containing a different version of the measurement result. Pattern interrupt. The framework was, at first, dismissed by most physicists. It was considered too strange, too philosophically expensive, too far removed from the practical concerns of physics. Wheeler eventually distanced himself from his students' proposal. Everett left academic physics for a career in operations research and never returned. The many worlds interpretation was, for the better part of 2 decades, a marginal idea. The status changed in the 1970s and 80s. Bryce DeWitt rediscovered Everett's work and promoted it within the physics community. David Deutsch, working at Oxford, developed it into a more complete framework and argued that it had concrete implications for quantum computing. The decoherence program, developed by Wojciech Zurek and others, provided a more concrete account of why the branches of the wave function become effectively independent after measurement. By the 1990s, the many worlds interpretation was being taken seriously by significant fractions of the foundations of quantum mechanics community. Today, the many worlds interpretation is, by some surveys, the most popular interpretation among working physicists in foundational research. It is not universally accepted. Significant fractions of the community continue to favour the Copenhagen interpretation, or some refined version of it, or alternative frameworks like the pilot wave theory of de Broglie and Bohm, or various epistemic interpretations that treat quantum mechanics as describing knowledge rather than reality. The debate is alive. For tonight, what matters is what the many worlds interpretation implies for the question of other versions of you. If the framework is correct, then every quantum event in your life has produced branches of cosmic history in which different outcomes occurred. There are branches in which the quantum events that led to your birth went differently, producing different people. There are branches in which you exist but made different choices. There are branches in which you made the same choices but the quantum events around you produced different consequences. The number of branches is, in the limit, enormous, possibly infinite. By the end of tonight, you're going to understand that the quantum multiverse is, in this sense, the most personally proximate of the 5 multiverses. The volume multiverse contains copies of you so far away that they are completely inaccessible. The bubble multiverse contains variants of you in separate cosmic bubbles. The quantum multiverse contains versions of you on branches of cosmic history that, at every moment, are diverging from your own. The other yous of the quantum multiverse are, in a strict mathematical sense, right next to you. They share your cosmic past up until the most recent quantum branch point. They diverge from you only in the choices and quantum events that have occurred since. Slowly we sit with the strangeness of this. Every moment of your life in the Everett picture has been a branching event. Every quantum event in your body, every quantum event in the air around you, every quantum event anywhere in the cosmos that could in principle affect you, has produced a branching of the wave function. The branches are growing exponentially in number every second throughout your entire life. The number of versions of you currently existing in the Everett tree is, in any meaningful estimate, beyond comprehension. The branches, however, do not interact. You cannot communicate with the other yous. You cannot meet them. You cannot, by any conceivable experiment, demonstrate their existence. They are, in this sense, mathematically required by the interpretation but observationally invisible. Whether they are real in the strongest sense depends on what you mean by reality. David Deutsch and Sean Carroll, among contemporary proponents of the many worlds interpretation, argue that the branches are as real as anything else in physics. They are predicted by the theory. They are required by the mathematical structure. They have observable consequences for any individual branch, even if the branches themselves cannot directly observe each other. The reality of the branches, in this view, is on the same footing as the reality of distant galaxies, or of past events, or of any other physical entity that we infer from theory, but do not directly experience. The textbook does not anticipate that the quantum multiverse would become, over 50 years, an increasingly mainstream framework among Foundation's physicists. The standard story is that the Copenhagen interpretation is correct, and that the wave function collapses, and that the other possibilities in the superposition simply disappear. The reality is that there is no consensus. The many worlds interpretation is, today, a serious candidate, and significant fractions of the community take it as the most likely correct framework. What this implies for your sense of singular existence is profound. If the many worlds interpretation is correct, then you are not the only you, even in your own immediate cosmic neighborhood. You are one of countless branches, each containing a slightly different version of your recent history. The branches multiply every second. The cosmic count of yous is increasing as you read this. By the time you finish this paragraph, billions of new branches will have appeared, each one containing a version of you who just read this paragraph with a slightly different mental state, in a slightly different room, in a slightly different cosmic moment. Tonight we're going to spend a longer stretch with the history of the Everett interpretation, because the story of how the many worlds picture went from being a marginal idea to being a mainstream candidate for the correct interpretation of quantum mechanics is one of the great quiet dramas of 20th century physics. Hugh Everett III was born in 1930 in Washington, D.C. He studied mathematics at Catholic University and then physics at Princeton. He arrived at Princeton in 1953 to begin doctoral work, originally under Eugene Wigner. He soon transferred to the supervision of John Wheeler, one of the great figures of mid-century physics, who was working on the application of quantum mechanics to gravity and cosmology. Everett's thesis, completed in 1957, was titled The Theory of the Universal Wave Function. The work was an attempt to apply quantum mechanics consistently to closed systems, including the universe as a whole. Everett noticed that the standard Copenhagen interpretation, which treats the observer as somehow external to the quantum system being measured, becomes inconsistent when applied to a system that contains the observer. If quantum mechanics is fundamental, then the observer is also a quantum system, and the observer's interaction with the measured system should be described by quantum mechanics rather than by some special collapse process. Everett worked through what this implies. If the observer is treated quantum mechanically, then the measurement process is a unitary interaction that produces entanglement between the observer and the measured system. The observer ends up in a superposition of states, each one corresponding to a different measurement outcome. The total quantum state contains all the possible outcomes, with each one paired with a version of the observer who recorded that outcome. Walk with me through what this means. The wave function in Everett's picture does not collapse. It continues to evolve according to the Schrödinger equation. The appearance of definite outcomes is explained by the fact that, after measurement, each branch of the wave function contains an observer who has recorded a definite outcome. The observer in any given branch only experiences their own branch. The other branches, with their other observers and other outcomes, are equally real but invisible to any observer in any specific branch. The thesis was, at the time, a radical departure from the Copenhagen orthodoxy that dominated quantum mechanics. Wheeler initially supported the work but became less enthusiastic over time, particularly after Niels Bohr, the principal architect of the Copenhagen interpretation, expressed skepticism. The thesis was published in a heavily edited form in the Reviews of Modern Physics in 1957. The longer version, which contained the more philosophically explicit discussion, was not published until 1973. Pattern interrupt. Everett left academic physics shortly after his thesis defense. He took a position with the Pentagon's Weapons Systems Evaluation Group, where he worked on game theory and nuclear strategy. He developed the field of Lagrangian optimization that later became important in operations research. He never returned to physics academic work. He died of a heart attack in 1982 at the age of 51, having received almost no recognition for his thesis during his lifetime. The Everett interpretation was, for the first 2 decades after its publication, a marginal idea. It was occasionally cited by physicists interested in the foundations of quantum mechanics, but it was not taken seriously by the mainstream. The Copenhagen interpretation, with all its philosophical difficulties, remained the standard textbook approach. The rediscovery began with Bryce DeWitt, a physicist at the University of Texas, who published a series of papers in the late 1960s and early 70s, arguing that Everett's interpretation deserved more serious consideration. DeWitt coined the term many worlds to describe the interpretation in place of Everett's more abstract universal wave function language. The new term was vivid enough to capture the imagination of a wider audience, and the framework began to attract attention. The next major development came from David Deutsch, working at Oxford. Deutsch published a series of papers in the 1980s and 90s, developing the many worlds interpretation into a more complete framework. He argued that the interpretation had specific consequences for quantum computation, and that the success of quantum computing algorithms could be understood as evidence for the existence of the parallel branches of the wave function. The argument is not universally accepted, but it gave the interpretation a concrete experimental connection that earlier versions had lacked. The decoherence program, developed by Wojciech Zurek, Eric Hughes, Heinz Dieter Zeh, and others, provided another major advance. Decoherence is the process by which the branches of the wave function become effectively independent after they have interacted with the environment. The interaction produces entanglement between the system and the environment in such a way that the different branches lose the ability to interfere with each other. From the perspective of any observer within a given branch, the other branches become unobservable. The decoherence program gave the many worlds interpretation a more concrete physical mechanism for the apparent independence of the branches. By the 1990s, the Everett interpretation had become a serious contender for the correct interpretation of quantum mechanics. Surveys of physicists working in the foundations of quantum mechanics began to show substantial fractions favoring the Everett picture. The interpretation was no longer marginal. It was, by some metrics, the most popular interpretation among researchers actively working on the foundations. By the end of tonight, you're going to understand that this is one of the most remarkable shifts in the foundations of quantum mechanics over the past half-century. The interpretation that was originally dismissed as too strange to take seriously has become a mainstream framework. The interpretation that Everett's thesis advisor distanced himself from has been adopted by significant fractions of the Foundation's community. The interpretation that produced no academic followers during Everett's lifetime has produced a substantial body of work in the decades after his death. The contemporary advocates of the Everett interpretation include some of the most prominent physicists working on foundational questions. David Deutsch continues to argue for the framework. Sean Carroll at Caltech has written extensively on it, including a popular book titled Something Deeply Hidden, published in 2019. Max Tegmark, who we encountered earlier in the context of the volume multiverse, also favours the Everett interpretation. The framework has, in this sense, attracted a substantial group of prominent researchers, in addition to its philosophical advocates. The opponents are also distinguished. Many physicists continue to favour the Copenhagen interpretation, often in refined modern forms that address some of the original difficulties. Others favour alternatives like the pilot wave theory of de Broglie and Bohm, in which a deterministic guiding equation supplements the wave function to produce definite outcomes without branching. Still others favour various epistemic interpretations, including cubism, which treat quantum mechanics as describing the knowledge of agents rather than physical reality. The debate is alive and unresolved. For the specific question of versions of you, the Everett interpretation has direct implications. Every quantum event in your life produces branching. The number of branches grows extraordinarily fast. The branches do not interact. Each branch contains its own version of you, with its own slightly different recent history. The total number of versions of you across the branching tree of the wave function is, by any reasonable estimate, beyond ordinary counting. The cosmic count in the Everett picture is generated continuously, at every moment, by the ongoing quantum events that affect your branch of cosmic history. Mark this thought. The quantum multiverse is the most personally close-in of the multiverses we're walking through tonight. The copies of you in this multiverse are not far away in space or time. They are everywhere your wave function has had the opportunity to branch. They are, in this sense, the cosmic version of an exponentially branching family tree, with you at one of the leaves and uncountable cousins on the other leaves. The third multiverse is the quantum multiverse. It is the most experimentally connected of the 5 frameworks. It depends on a theory, quantum mechanics, that has been verified to extraordinary precision. The interpretation of that theory remains contested. If the Everett interpretation is correct, the cosmic count of versions of you is, in every meaningful sense, enormous. The branches do not interact. The branches multiply continuously. The branches contain every quantum possible variant of your existence. The fourth multiverse is the most abstract of the five, and it is the one that requires the most philosophical commitment to take seriously. It is the mathematical multiverse, sometimes called the mathematical universe hypothesis, proposed in its modern form by Max Tegmark over the past 2 decades. Tonight we're going to walk into this carefully, because the mathematical multiverse asks us to take an unusual claim seriously. The claim is that all mathematically consistent structures exist as physical realities, not just our specific universe with its specific laws of physics. Every possible mathematically coherent universe, defined by every possible mathematically coherent set of laws, exists in the same robust sense that our universe exists. The argument begins from a simple observation. Physics has, over the past 4 centuries, been increasingly successful at describing the natural world through mathematics. The laws of physics are written in mathematical language. The fundamental equations of general relativity, of quantum field theory, of statistical mechanics, are all mathematical structures. The deeper the physics goes, the more mathematical it becomes. Tegmark's argument is that this trend is not accidental. Mathematics is not just a useful tool for describing reality. Mathematics is what reality is made of. Slowly we work through the implications. If our universe is, at its deepest level, a mathematical structure, then the question of why this particular mathematical structure exists rather than some other one becomes salient. Most mathematical frameworks treat mathematical structures as existing independently of any physical instantiation. The Pythagorean theorem is true regardless of whether anyone has ever drawn a right triangle. The properties of prime numbers exist regardless of whether any physical universe ever computes them. Mathematics, in this traditional view, has its own kind of existence, separate from physical reality. Tegmark's proposal is to take this view to its logical conclusion. If mathematical structures exist independently of physical instantiation, and if our universe is itself a mathematical structure, then all mathematically consistent structures exist in the same way. Our universe is one such structure. Other universes, corresponding to other mathematical structures, exist with equal ontological standing. The collection of all such structures forms the mathematical multiverse, sometimes called the level 4 multiverse in Tegmark's numbering scheme. Pattern interrupt. The level 4 multiverse contains, by construction, every possible variant of physical law, universes with different numbers of spatial dimensions, universes with different fundamental forces, universes with no time, universes with multiple time dimensions, universes whose laws bear no resemblance to ours. The level 4 multiverse is, in this picture, the most permissive multiverse possible. It contains everything that mathematics allows. Among the structures in the level 4 multiverse, some contain conscious observers. Most do not. Some of the structures with conscious observers are similar to our own universe, with similar laws and similar histories. Some of them, by mathematical necessity, contain versions of you. The versions are not biological copies in the strict sense. They are mathematical structures whose internal dynamics produce conscious states identical or similar to yours. The mathematics of consciousness, whatever it turns out to be, defines a subspace of the level 4 multiverse in which observers similar to you exist. By the end of tonight, you're going to understand that the level 4 multiverse contains, in its most expansive form, not just other versions of you with different histories, but other versions of you implemented in fundamentally different mathematical structures. There could be a version of you living in a universe with no time, whose entire existence is a single timeless mathematical fact, rather than a sequence of moments. There could be a version of you in a universe with 7 spatial dimensions, whose body and brain are arranged in geometric patterns that have no analogue in 3-dimensional space. There could be a version of you in a universe governed by laws no physicist in our universe has ever conceived, whose consciousness emerges from structures fundamentally different from neurons. Take a moment to sit with how strange this is. The mathematical multiverse does not just contain alternative physical universes, it contains alternative metaphysical universes with different fundamental ontologies. Our universe runs on quantum field theory operating on space-time. Other universes in the level 4 multiverse run on whatever mathematical structures are consistent, whether or not they resemble anything in our physics. The cosmic count of universes in this picture is bounded only by the count of mathematical structures, which is, in any sense that matters, infinite. The framework is the most controversial of the 5 we're walking through tonight. Most working physicists do not take the level 4 multiverse seriously. The arguments against it are several. Some critics argue that mathematical structures do not exist independently of physical instantiation, which would invalidate the basic ontological move. Others argue that even if mathematical structures do exist, the move from mathematical existence to physical existence is unwarranted. Still others argue that the framework is unfalsifiable, since it makes no specific predictions that could be tested. The defenders, including Tegmark himself, argue that the framework is the natural conclusion of taking the mathematical structure of physics seriously. They point out that no specific feature of our universe seems to require its own existence over the existence of any other consistent mathematical structure. Why should our universe exist and not another one? The level 4 multiverse provides an answer. All consistent structures exist. Our universe is one of them. The question of why this one exists becomes the question of which one we happen to be inside, which is a much weaker question than the original. Step by step, we trace what this implies for the question of other yous. In the level 4 multiverse, the versions of you are not just copies in some other physical bubble. They are mathematical implementations of patterns similar to the patterns that produce your consciousness. The copies exist in mathematical structures completely different from ours. Some of them are in universes that share many properties with ours. Others are in universes that share almost nothing. The cosmic count in this picture is, by every available measure, infinite in the strongest possible sense. The level 4 multiverse contains all mathematical structures. The structures containing variants of you are a subset of those, but a subset that is itself infinite. The count of conscious observers similar to you across the full multiverse exceeds any cardinality that ordinary counting can handle. Tonight we're going to spend a careful pass on the philosophical structure of the mathematical universe hypothesis, because the framework deserves to be understood in its strongest form, not in caricature. The mathematical universe hypothesis was developed by Max Tegmark over a series of papers beginning in 1998 and culminating in his 2014 book, Our Mathematical Universe. The core claim is deceptively simple. Our external physical reality is a mathematical structure. Take a moment to sit with what this claim actually says. It is not the claim that physics uses mathematics to describe reality. That claim is uncontroversial and has been the basis of physics since at least Galileo. It is not the claim that mathematics provides an effective language for physical theory. That claim, while more philosophically rich, is also widely accepted. The mathematical universe hypothesis says something stronger. It says that our physical reality is, at its deepest level, identical to a mathematical structure, in the same sense that the number 3 is identical to a mathematical entity. The motivation for this claim comes from a recurring observation in the history of physics. As physical theories become more fundamental, they become more mathematical. The classical mechanics of Newton describes physical objects using mathematical equations, but the objects themselves are still picturable. The general relativity of Einstein describes space-time using more abstract mathematical structures, including curved manifolds and tensor equations. The quantum field theories of the Standard Model describe particles as excitations of mathematical fields that have no direct picturable interpretation. The deeper the physics goes, the further from direct picturability the underlying entities become, and the more mathematical they become. Tegmark's argument is that this trend is not accidental. If physics is converging on a fully mathematical description of reality, then the most natural conclusion is that reality is mathematical. The mathematical structures we use to describe reality are not just useful tools, they are what reality actually is. Pattern interrupt. The mathematical universe hypothesis has several immediate consequences that follow with little additional reasoning. First, every mathematical structure that exists in the same way our universe exists. The reasoning is that there is nothing special about our specific mathematical structure that would single it out as the one to be physically realized. If our universe exists by virtue of being a particular mathematical structure, then other mathematical structures should exist for the same reason. Slowly we work through what this implies. The space of all mathematical structures is enormous. It contains finite structures, infinite structures, structures with various levels of internal symmetry, structures with various kinds of dynamics. It contains structures corresponding to mathematical objects that physicists have studied, like the various space-times of general relativity, the various Lie groups of particle physics, and the various Hilbert spaces of quantum mechanics. It contains structures corresponding to mathematical objects that physicists have not yet studied, including ones that may have no physical analogue in our universe. Each mathematical structure, if Tegmark is correct, exists in the same robust sense that our universe exists. The structures that contain conscious observers similar to us are a subset of the total. Among those, some are similar to our universe in detail, others are similar in broad features but differ in specifics. Others are radically different from our universe, but still contain consciousness in some form. By the end of tonight, you're going to understand that the cosmic count of universes in the Level 4 picture is bounded only by the count of mathematical structures, which is, by every standard measure of size, infinite in a strong sense. The count of universes containing variants of U is a subset of this infinity, but it is still infinite in its own right. The mathematical universe. Hypothesis generates, in its most expansive form, more universes than any of the other multiverse frameworks. The hypothesis has been the subject of substantial philosophical critique. The most common objections fall into several categories. First, the hypothesis depends on the assumption that mathematical structures have a particular kind of existence independent of physical instantiation. This assumption, while accepted by some philosophers of mathematics, is rejected by others. The Platonist position, that mathematical objects exist abstractly, is one option among several in the philosophy of mathematics. Other positions, like the formalist position, that mathematics is a system of symbols without referent, would undermine the basic move of the mathematical universe hypothesis. Second, the hypothesis has been criticized for being unfalsifiable. It makes no specific predictions about features of our universe that could be tested by observation. The claim that all consistent mathematical structures exist is, by construction, compatible with any observation about our specific universe. Critics argue that this lack of testability disqualifies the hypothesis as a scientific claim. Tegmark and his defenders respond that the hypothesis is a metaphysical claim about the nature of reality, not a scientific claim subject to empirical test, and that the lack of testability does not, by itself, make the claim implausible. Third, the hypothesis has been criticized for problems with measure. When you postulate the existence of an infinite collection of structures, you face the technical problem of how to assign probabilities to different structures. The simplest measures, like uniform distribution over all structures, run into problems because the space of all structures is too large to admit a sensible uniform measure. More sophisticated approaches, including measures based on algorithmic complexity, have been developed, but they remain controversial. Few would anticipate, on first encountering the mathematical universe hypothesis, that the framework would attract serious philosophical engagement from both supporters and critics over a sustained period. Few of us anticipate that the question of whether mathematical structures are physically real would become a topic of serious work in the foundations of physics. Almost nobody anticipates the way the hypothesis, despite its apparent strangeness, has become one of the live options in contemporary metaphysics of physics. walk slowly with one specific consequence of the mathematical universe hypothesis that is particularly relevant for tonight's question. If all consistent mathematical structures exist, and if our consciousness is itself a mathematical pattern of some kind, then any mathematical structure that contains a substructure equivalent to your consciousness contains a version of you. The version of you in that structure may be embedded in a universe that looks nothing like ours. The universe may have different physical laws, different number of dimensions, different kinds of fundamental entities, but the pattern that constitutes your consciousness, if it appears in some substructure of the larger mathematical universe, produces a conscious experience equivalent to yours. By the end of tonight, you're going to understand that this means the Level 4 multiverse contains versions of you embedded in universes that are radically different from ours in fundamental ways. Your consciousness in this picture is portable across mathematical structures. Wherever the right pattern appears, you appear. The versions of you across the Level 4 multiverse are not limited to copies in universes similar to ours. They include implementations in mathematical structures that we cannot even fully describe with our current mathematics. This is, by any reasonable measure, the most expansive picture of cosmic versions of you in modern thought. The Level 4 multiverse, taken at its strongest form, contains every possible consistent mathematical implementation of consciousness similar to yours. The number is, in any meaningful sense, beyond ordinary counting. Hold the thought. The Level 4 multiverse is the most expansive of the multiverse frameworks. It is also the most philosophically expensive. To accept it requires accepting that mathematical structures are physically real, in the same sense that you and your room are physically real. The acceptance is not forced by any current data. It is a philosophical commitment that goes beyond what physics requires. But the framework is not crackpot. It is taken seriously by serious philosophers and physicists, including not only Tegmark but a substantial number of younger researchers in the foundations of physics. The framework has been published in major journals. It has been the subject of philosophical conferences. It is today one of the live options in the metaphysics of modern cosmology. What this means for tonight's question is that the Level 4 multiverse provides, in some sense, the maximally generous answer to the question of whether other versions of you exist. The volume multiverse says yes, by combinatorial necessity, in our infinite spatially flat cosmos. The bubble multiverse says yes, by cosmological inflation, in the other bubbles of the inflating cosmos. The quantum multiverse says yes, by quantum branching, on the other branches of the cosmic wave function. The mathematical multiverse says yes, by ontological necessity, in every mathematical structure that can support consciousness similar to yours. The textbook does not anticipate that the question of who you are has, in its modern form, become a question about which mathematical structure you happen to be inside. Few of us anticipate that the increasingly mathematical character of physics has, over the past century, gently pushed the foundational questions about reality in directions that would have seemed bizarre to physicists a century ago. Almost nobody anticipates the way the mathematical universe hypothesis, despite its philosophical strangeness, has become one of the more interesting frontiers of modern theoretical work. The fourth multiverse is therefore the most extreme of the four we have walked through so far. It contains, by construction, every possible coherent variant of physical law and every possible coherent variant of you. The count is infinite in a stronger sense than the count in the previous three multiverses. The framework is more controversial than the other three. The framework is also, in its way, the most elegant. It explains why our universe exists, by reducing the question to the question of which mathematical structure we are inside. The fifth multiverse is the most unsettling of the five, because it does not require any speculative cosmology or any specific interpretation of quantum mechanics. It depends only on the observation that we, as a civilization, are getting better at running simulations, and on the assumption that this trend will continue. The fifth multiverse is the simulated multiverse, Tonight we're going to walk into this carefully because the simulation argument has had an unusual reception. Originally proposed in 2003 by Nick Bostrom, a philosopher at Oxford, the argument has been embraced by some thinkers, dismissed by others, and remains the subject of serious debate 20 years later. It is one of the few philosophical arguments to have had a measurable impact on how some technologists, including Elon Musk, talk publicly about their views of reality. The argument runs as follows. Consider 3 propositions and observe that at least one of them must be true. First proposition. Civilizations capable of running large numbers of high-fidelity simulations of conscious observers almost always go extinct before reaching that capability. Second proposition. Civilizations that reach such capability almost always choose not to run such simulations. Third proposition. We are almost certainly living in a simulation. The argument's force comes from the fact that the third proposition follows from the falsity of the first two. If some civilizations reach the capability of running detailed simulations, and if some of those civilizations choose to actually run such simulations, then the number of simulated observers vastly exceeds the number of base reality observers. By simple counting, any given observer is much more likely to be simulated than to be at the base level of reality, including you, including me. Slowly, we trace the basic counting. Suppose, hypothetically, that one civilization in the cosmos eventually develops the technology to run high-fidelity simulations of itself and its history. The simulations contain conscious observers indistinguishable from the inside from the original. The civilization runs, say, 1,000 such simulations over its history, each one containing 1 billion conscious observers. The total simulated observer count is therefore on the order of 1 trillion, vastly larger than the few billion non-simulated observers in the base civilization. If you're picked at random from the set of all observers who have ever experienced what you're experiencing right now, you're far more likely to be one of the trillion simulated observers than to be one of the few billion base reality observers. The base reality observers are a tiny minority. The simulated observers dominate the cosmic count. The simulation argument therefore concludes that, conditional on the first 2 propositions being false, you are almost certainly simulated. Pattern interrupt. The argument has a number of subtle features that deserve careful attention. First, it does not require that we ever actually develop the simulation technology. It only requires that some civilization, anywhere in the cosmos, ever does. Even if our specific civilization goes extinct or chooses not to run simulations, the argument still works if any other civilization, anywhere in cosmic history, does run them. Second, the argument does not specify what kind of base reality the simulators are operating in. The simulators might themselves be in a simulation, run by a higher level of reality. The chain of simulations might extend indefinitely. We could be at any level of the chain. Take a moment to sit with this. The simulation argument does not assert that we are simulated. It asserts that one of 3 propositions is true. The first proposition, that civilizations go extinct before developing simulation capability, would have major implications for the prospects of any technological civilization, including ours. The second proposition, that capable civilizations choose not to run simulations, would imply a substantial degree of restraint that may or may not be plausible. The third proposition, that we are simulated, would have implications for everything from physics to ethics to the nature of consciousness. Bostrom himself does not strongly endorse any one of the 3 propositions. He argues that all 3 should be taken seriously, and that the choice between them depends on assumptions about the long-term behavior of civilizations and the values of advanced beings. Other commentators have taken stronger positions. Some, including the philosopher David Chalmers in his recent book Reality Plus, argue that the simulation hypothesis is taken seriously enough that its implications deserve careful work. Others, including a range of philosophers and physicists, regard the argument as resting on assumptions that are too speculative to support its strong conclusion. For tonight, What matters is what the simulation multiverse implies for the question of versions of you. If you are simulated, then you exist as a particular instance within the larger simulation. The simulation may contain other instances of you, perhaps run under slightly different initial conditions to study what would have happened with different cosmic histories. The simulators may run many copies of the simulation, each with slight variations, producing many versions of you across the ensemble of runs. The cosmic count of versions of you in the simulation multiverse depends on how many simulations are run, how many variants each simulation includes, and how many copies of you appear in each variant. The numbers can be large. Some recent analyses, including work by computer scientists who have thought carefully about the scaling of simulation technology, suggest that an advanced civilization could run trillions of high-fidelity simulations simultaneously, each containing many variants of every observer. For the next stretch, we should sit with one more layer of the simulation multiverse, the nesting. If we are in a simulation, the simulators above us may themselves be in a simulation, run by an even higher level of reality. There may be many levels in the chain. Each level, in principle, could run many simulations of the level below. The full hierarchy of simulations contains a vast number of conscious observers distributed across many levels, with versions of you appearing in many of them. The cosmic count of yous, in the full nested simulation hierarchy, is, in any meaningful sense, enormous. The empirical status of the simulation argument is one of its most distinctive features. Unlike the other four multiverses, the simulation argument may have testable implications. Several physicists have proposed experiments that could, in principle, detect signatures of simulation. The argument is that any simulation runs on finite computational resources and that the underlying simulation must therefore make approximations to model the physical world. Some of those approximations might be detectable through careful experiments. For example, if the simulation uses a discrete lattice to model spacetime, the discreteness might be detectable through observations of high-energy cosmic rays. Several experimental searches have been conducted, with null results so far. The absence of detection does not rule out simulation. It rules out specific implementations. By the end of tonight, you're going to understand that the simulation multiverse occupies a curious position relative to the other four. The volume, bubble, quantum, and mathematical multiverses are all framed in terms of physical or mathematical reality. The simulation multiverse is framed in terms of computational reality, and it has direct implications for how we should think about consciousness and free will. If we are simulated, then our experiences are real, but they are mediated by a computational substrate that may not resemble the world we observe. The textbook does not anticipate that a serious philosophical argument from the early 21st century would produce an additional multiverse framework with potentially testable consequences. The standard story is that questions about cosmic multiplicity are addressed by cosmology and quantum mechanics. The simulation argument adds a separate dimension to the conversation, one rooted in computer science and philosophy of mind rather than physics. What this leaves us with is a fifth multiverse that is distinct from the previous four in several important ways. The simulation multiverse depends on assumptions about the behavior of advanced civilizations, rather than on assumptions about physical or mathematical structures. The simulation multiverse may have empirical signatures, while the other four are essentially untestable. The simulation multiverse implies that the apparent physical reality we observe may be a constructed artifact, while the other four take physical reality at face value but extend its scope. Tonight we're going to spend more time with the specific structure of the Bostrom simulation argument, because the argument has been widely repeated in popular discussion, but is rarely presented with the precision that gives it its actual force. Nick Bostrom is a philosopher who has spent his career at Oxford University, where he founded and directs the Future of Humanity Institute. His training is in physics, mathematics, and philosophy. His work has focused on existential risk, the long-term future of humanity, and the implications of advanced technology. The simulation argument, published in 2003 in the Philosophical Quarterly, was developed as part of his broader interest in the long-term trajectory of intelligent civilizations, take a moment to sit with the actual structure of the argument, because the structure matters more than the headline. The argument is technically a trilemma. It does not assert that we are in a simulation. It asserts that at least one of three propositions must be true. The three propositions are these. Proposition 1. Almost all civilizations at our current stage of technological development go extinct before reaching the capability to run high-fidelity simulations of conscious observers. Proposition 2. Among civilizations that do reach this capability, almost none of them choose to run a substantial number of such simulations. Proposition 3. We are almost certainly in a simulation. The argument's force comes from a counting argument applied to the relative populations of simulated and non-simulated observers. Suppose, hypothetically, that propositions 1 and 2 are both false. Then some civilizations reach the simulation capability, and some of them choose to run significant numbers of simulations. The simulated observers in those simulations vastly outnumber the non-simulated observers in the base reality. Any observer chosen at random from the full population of observers across cosmic history, in this hypothetical case, is overwhelmingly likely to be simulated. The argument applies this counting to you. If you are a randomly selected observer from the population of all observers with experiences like yours, and if simulated observers vastly outnumber non-simulated ones, then you are overwhelmingly likely to be simulated. The conclusion follows from the counting, conditional on the falsity of the first two propositions. Pattern interrupt. The argument has several subtle features that deserve careful attention. First, the argument does not require that we ever build simulations. It only requires that some civilization anywhere in the cosmos and at any time in cosmic history has built or will build them. If even one civilization has run simulations of observers like us, the counting argument applies. Second, the argument is symmetric across cosmic time. Past, present, and future civilizations all contribute to the population of simulators. Third, the argument is symmetric across cosmic space. Simulators could exist in any galaxy, in any era, on any planet capable of supporting advanced technology. The argument is also recursive. If we are in a simulation, the simulators may themselves be in a simulation. The chain of simulations may extend indefinitely. At any given level of the chain, the inhabitants of that level may or may not realize they are simulated. The recursive structure adds complexity, but does not undermine the basic counting argument. The total population of conscious observers across all levels of the chain may include vast numbers of simulated beings, with non-simulated beings concentrated at the very top of the chain, if there is a top. What this picture tells us is that the argument has provoked such varied reactions. Some thinkers find it a powerful and important argument that deserves to be taken with full seriousness. Others find the assumptions implausible enough that the argument does not carry much weight. Still others find the argument philosophically intriguing but practically irrelevant, in the sense that the question of whether we are simulated has no clear implications for how we should live our lives. The variation in reactions reflects the variation in how people respond to philosophical arguments more generally. Slowly, we walk through some of the standard objections. The first objection is that high-fidelity simulation of conscious observers may not be physically possible, even for an advanced civilization. The argument that consciousness can be implemented on any sufficiently powerful computational substrate is taken for granted in the Bostrom framework, but it is not uncontroversial. Some philosophers, including David Chalmers, have argued in favor of substrate independence of consciousness. Others, including some physicists who think consciousness depends on specific physical processes, have argued against. If consciousness cannot be implemented in arbitrary computational substrates, the simulation argument fails. The second objection is that the assumption about the typical behavior of advanced civilizations may not be justified. The argument assumes that advanced civilizations are likely to run simulations, but the reasons for this assumption are not strong. Civilizations may choose not to run simulations for ethical reasons, for resource reasons, or for reasons we cannot anticipate. The argument depends on a substantial fraction of civilizations choosing to simulate, and the assumption that they will is contested. The third objection is that the argument may be self-undermining. If we are in a simulation, then our information about the behavior of civilizations and the physical constants of our universe may be artifacts of the simulation rather than reflections of the base reality. We may therefore be unable to reason reliably about the probability of being simulated, because our reasoning depends on data that may not reflect the actual situation. The objection is subtle, but has been pressed by various philosophers. Walk slowly with one more aspect of the simulation framework that is empirically interesting. Several physicists have explored the possibility that simulations might have observable signatures. The reasoning is that any simulation runs on finite computational resources. To model a continuous physical world, the simulation must use discrete approximations. The discreteness might be visible in physical phenomena, particularly at extreme scales of energy or precision. One specific proposal, published in 2012 by Silas Bean and his collaborators, suggests that ultra-high-energy cosmic rays might show signatures of a discrete space-time lattice, if the cosmos is being simulated on such a lattice. The proposal involves looking for cutoffs in the energy spectrum of cosmic rays that would correspond to the lattice scale. Searches have been conducted, and the results have placed limits on the lattice scale, but no positive detection has been made. The absence of detection is consistent with several possibilities, including that the simulation does not use a lattice approximation, that the lattice is finer than current observations can probe, or that the simulation hypothesis is incorrect. What surfaces from this is that the simulation argument occupies a unique position among the multiverse frameworks we have walked through tonight. Unlike the others, it has potentially testable consequences. Unlike the others, it depends on assumptions about the behavior of conscious beings rather than on physical or mathematical principles. Unlike the others, it has direct implications for how we should think about the apparent physical reality we observe. The argument is, in this sense, both more empirically connected than the other multiverses and more philosophically loaded. For the question of versions of you, the simulation argument suggests several distinct categories of other yous. There are the variants of you in other runs of the same simulation, if multiple runs are performed by the same simulators. There are the variants of you in different simulations run by the same simulators. There are the variants of you in simulations run by different simulators at different cosmic times. There are the variants of you at different levels of the nested simulation hierarchy, if the chain extends indefinitely. What this leaves us with is a fifth multiverse that contains, in principle, a vast population of you variants. The variants are not generated by quantum branching or cosmic inflation. They are generated by the choices of conscious beings running simulations. The structure of the variant population reflects the choices of those beings rather than the laws of physics. The simulation multiverse, in this sense, is the most personally constructed of the 5 frameworks. It depends on intentional creation rather than on cosmic process. Hold this image. We have now walked through 5 distinct frameworks, each of which suggests that other versions of you exist. The volume multiverse, by combinatorics in infinite flat space, the bubble multiverse, by inflationary nucleation of separate cosmic regions, the quantum multiverse, by Everett branching of the wave function, the mathematical multiverse, by ontological commitment to all consistent structures, the simulation multiverse, by the demographics of computational realities run by advanced civilizations. Each framework, taken on its own terms, generates infinite or near-infinite versions of you. The frameworks are not mutually exclusive. They can be true simultaneously. If they are all true, the cosmic count of yous is, in the strongest possible sense, beyond any meaningful counting. You exist as a multitude, in multiple senses, across multiple frameworks of reality. The 5th multiverse, the simulated one, is in some ways the most personal of the 5. The simulators, if they exist, are conscious beings making decisions about what to simulate and how. The other U's in the simulation hierarchy are not just statistical consequences of cosmic geometry or quantum mechanics. They are deliberate creations of someone, run for some purpose, with some intention behind their existence. Whether this is a more comforting thought or a more disturbing one depends on what you assume about the intentions of the simulators. Tonight, we're going to step back from the 5 frameworks and ask how they relate to each other, because the relationships between the multiverses are themselves part of the story, and the relationships are often misunderstood. Before we get started on the structure, sit with the basic observation. The 5 multiverses we have walked through are not 5 competing theories of the same phenomenon. They are 5 distinct frameworks, each emerging from different starting assumptions, each generating its own conclusions. They are not mutually exclusive. They can be true simultaneously. They can also be false simultaneously. The relationship between any two of them is not one of competition, but of layering. No one expects, on first encountering multiverse cosmology, that the frameworks would stack on top of each other rather than compete with each other. No one predicts that taking all 5 seriously simultaneously is consistent rather than contradictory. Absolutely no one anticipates the way the multiple multiverses, considered as a single coherent picture, multiply the cosmic count of versions of you rather than dividing it. Pattern interrupt. The simplest way to see the relationship is to note that each multiverse adds copies of you on top of the previous ones. The volume multiverse adds infinite identical copies through cosmic geometry. The bubble multiverse adds infinite variants through inflationary cosmology, each one in a different bubble of the inflating background. The quantum multiverse adds infinite branches through quantum measurement, multiplying every second as the wave function decoheres. The mathematical multiverse adds infinite implementations through ontological commitment to all consistent structures. The simulation multiverse adds infinite instances through computational creation by advanced observers. If all 5 are true, the total count of U variants is the product of the 5 contributions, each of which is, in the limit, infinite. The result is, in any meaningful mathematical sense beyond any standard counting, the cosmic ensemble of versions of you contains infinities layered on top of infinities, with the structure of the layering reflecting the different mechanisms by which each multiverse contributes its copies. Now, let's begin to think about whether the frameworks are equally well supported. The answer is no. The frameworks differ substantially in their empirical and theoretical foundations. The volume multiverse depends only on the assumption that the cosmos is spatially flat and infinite. The flatness has been verified to within about 1% by CMB measurements. The infinite extent is the simplest extrapolation but is not directly tested. The framework is, in this sense, the most conservative of the 5. The bubble multiverse depends on the eternal inflation framework. Inflation itself is well supported by multiple lines of evidence. Eternal inflation is a specific extension of inflation that is taken seriously by significant fractions of the cosmology community, but is not universally accepted. The framework is, in this sense, more speculative than the volume multiverse. The quantum multiverse depends on the many worlds interpretation of quantum mechanics. Quantum mechanics itself is one of the most precisely tested theories in physics. The interpretation of quantum mechanics remains contested. The many worlds picture is taken seriously by significant fractions of Foundation's researchers, but is not universally accepted. The framework is, in this sense, on roughly the same epistemic footing as the bubble multiverse. The mathematical multiverse depends on a specific metaphysical commitment to the independent existence of mathematical structures. The commitment is taken seriously by some philosophers and physicists, but is not part of any mainstream physical theory. The framework is, in this sense, more philosophically loaded than the previous 3. The simulation multiverse depends on assumptions about the long-term behavior of advanced civilizations. The assumptions are taken seriously by some thinkers but are far from established. The framework is, in this sense, the most speculative of the 5 in its empirical foundations, though it may have testable consequences that the other frameworks lack. Notice that the 5 multiverses span a spectrum of epistemic confidence. The volume multiverse is the most conservative. The simulation multiverse is the most speculative. The other 3 lie in between. The question of which ones to take most seriously depends on which assumptions you're most willing to grant. Expectation. There is a definitive answer to whether the multiverse is real. Reality. The answer depends on which of the 5 frameworks you consider, and each of the 5 has its own degree of empirical and theoretical support. Tonight, we're going to consider what this implies for thinking about the question we started with. If you ask whether other versions of you exist, the honest answer is that it depends on which multiverse framework you're willing to accept. Under the volume multiverse, yes, with very high confidence, because the assumption of infinite flat space is the most natural extrapolation of current observations. Under the bubble multiverse, probably, conditional on the eternal inflation framework being correct. Under the quantum multiverse, yes, if the Everett interpretation is correct. Under the mathematical multiverse, yes, if the mathematical universe hypothesis is correct. Under the simulation multiverse, yes, if advanced civilizations run simulations and we're likely to be in one. The cumulative probability that at least one of the 5 frameworks is correct, conditional on the independent probabilities of each, is substantial. Even if each individual framework has only modest probability of being correct, the probability that at least one is correct can be large. This is one of the more robust conclusions of the multiverse picture. The probability that no version of you exists outside your immediate environment, given the combined weight of the 5 frameworks, is small. Mark this moment. Sit with this. The case for other versions of you does not depend on any one of the 5 frameworks being correct. It depends on the combined weight of the frameworks together. Even a skeptic who rejects any specific multiverse framework as too speculative may find the combined case for other versions of you difficult to dismiss entirely. Now, let's begin to think about the philosophical implications of accepting the multiverse picture in its strongest form. If you accept that other versions of you exist across multiple multiverses, several questions become salient. What is the relationship between you and the other versions? Are they morally significant in the same way that other people in your immediate environment are? Do their choices affect your responsibilities? Do their experiences count as part of your overall experience, or are they entirely separate? These questions have been addressed by various philosophers and ethicists. The consensus, to the extent that one exists, is that the other versions are morally significant in some sense, but do not affect your immediate responsibilities. The reasoning is that you have no causal contact with them. Your choices do not affect their lives. Their choices do not affect your life. The two of you are, in a sense, parallel beings, each living your own life without interaction. What this leaves us with is that this is one of the more comforting features of the multiverse picture. The existence of other versions of you does not increase your moral burdens. It does not require you to consider their interests when making decisions. It does not give you new responsibilities. The other versions are simply there, in their own corners of cosmic reality, living their own lives. Their existence is a feature of the cosmos, not a demand on your ethical attention. Before we get started on the close, take a moment with one more reflection. The multiverse in its strongest form suggests that everything possible has happened somewhere. Every choice you have ever made has been made differently by some version of you. Every event in your life has unfolded differently in some other branch. The full ensemble of versions of you covers every possible variant of your existence. This thought can be either liberating or anxious-making, depending on how you approach it. The liberating reading is that you do not need to feel singular responsibility for your own outcomes, because every possible outcome has been realized by some version of you somewhere. The anxious reading is that nothing you do is unique, because every choice you make has already been made differently in some other branch. The textbook does not anticipate that modern physics would produce a framework with such direct emotional implications. The standard story is that physics is about objective reality. separate from how we feel about it. The reality is that the multiverse picture, if accepted, has substantial implications for how you might feel about your own life and choices. No one predicts the consequence, but it is real. The implications are not forced. You can accept the multiverse picture without changing your daily life, but the picture, once accepted, sits in the background of how you think about your singular existence. What this leaves us with is a picture in which the question of other versions of you has multiple coherent answers, each one corresponding to a different multiverse framework. The frameworks layer on top of each other. The combined picture suggests that the cosmic count of versions of you, integrated across all the frameworks, is, in the strongest possible sense, enormous. The other versions are unreachable. They do not affect your decisions. They simply exist in their own corners of cosmic reality. Tonight, we're going to spend a careful pass on what the multiverse implies for the way you live, because the question matters more than the question of whether the multiverse exists. Before we get started, sit with the basic situation. You're reading these words in a particular body, in a particular room, on a particular night. The body has memories, plans, fears, loves. The room has a temperature, a smell, a quality of light. The night has its own quiet. None of this changes whether or not the multiverse is real. The multiverse, if it exists, is something the cosmos contains. You are something the cosmos contains. The relationship between you and the multiverse is the relationship between any conscious being and the larger structure of reality. The first question worth asking is whether accepting the multiverse changes the meaning of your choices. The intuition that your choices matter depends in part on the assumption that you are the only one making them. If other versions of you are making different choices in different multiverses, does your specific choice still matter? No one expects, on first thinking about this, that the answer might be yes in some senses and no in others. No one predicts that the question of choice meaning would have different answers in different frameworks. Absolutely no one anticipates the way the philosophical implications of the multiverse turn out to be more nuanced than the cosmological implications. Step back. The most defensible answer on careful examination is that your choices matter in the sense that they determine the trajectory of the version of you that you are. They do not matter in the sense of determining the cosmic outcome across all versions of you. Across all versions of you, every possible choice has been made by some version. The choices are, in this cosmic sense, redundant, but the choice made by your specific version is the choice that determines your specific life. The choices matter from your perspective. They do not matter from the cosmic perspective. The second question is whether accepting the multiverse changes the meaning of suffering. If every possible suffering has occurred somewhere across the multiverse, does your specific suffering have less weight? The temptation is to think yes. The full population of suffering experiences across the multiverse is so vast that any individual instance might seem trivial by comparison. What emerges from this is that this is a mistake. The full cosmic population of suffering does not diminish the weight of any individual instance. Suffering is experienced from the inside. The cosmic count does not enter the experience. A version of you somewhere across the multiverse suffering is suffering. The fact that other versions of you elsewhere are also suffering does not lighten any individual instance. The cosmic perspective and the personal perspective are independent. Both are valid. Neither cancels the other. The third question is whether accepting the multiverse changes the meaning of love. If you love someone in this version of cosmic reality, does it matter that other versions of you elsewhere love different people, or do not love at all? The temptation again is to think the cosmic perspective dilutes the personal one. Now let's begin to walk through why this is also a mistake. Love, like suffering, is experienced from the inside. The love you feel for the people in your life is the love you feel for the people in your life. It is not diminished by the fact that other versions of you elsewhere feel love for different people. The cosmic ensemble of love experiences is vast and varied. Your specific love is one instance in that vast ensemble. The ensemble does not make your specific instance less real or less significant. Before we get started on the deeper implications, take a slow breath here. The multiverse, if it exists, does not change the structure of your immediate experience. Your room is still warm. Your memories are still yours. The people you love are still the people you love. The choices in front of you are still the choices in front of you. The cosmic backdrop has expanded in unexpected ways, but the foreground of your life remains where it has always been. This is, in some sense, the most important practical conclusion of the multiverse picture. Accepting that other versions of you exist does not change how you should live your specific life. The other versions are unreachable. They cannot give you advice, they cannot share their experiences with you, they cannot benefit from your wisdom or pay for your mistakes. They are simply there, parallel to you, living their own lives. Your life remains yours to live, in the same way it would be yours to live in a universe without a multiverse. Expectation, accepting the multiverse, will fundamentally change how you understand your life. Reality, accepting the multiverse changes the cosmic backdrop but leaves the foreground of your life untouched. The fourth question is whether the multiverse changes the meaning of mortality. If other versions of you exist, does your death still matter? The temptation is to think that death is less final if the cosmos contains other yous who continue to live. No one predicts that this would also turn out to be a misreading of what the multiverse implies. No one expects that the cosmic backup of your existence would not actually function as a backup in any meaningful sense. Absolutely no one anticipates that the other versions of you are, despite being structurally similar to you, fundamentally separate from you, in a way that prevents them from continuing your existence after your death. Slow down here. The other versions of you, whatever their structural similarity to you, are not continuations of your particular consciousness. They are parallel instances of consciousness that resemble yours. When your particular consciousness ends, it ends. The fact that other consciousness similar to yours continues elsewhere does not extend your specific consciousness. Death, in the multiverse picture, is still death for the specific you that you are. The cosmic backup does not save you. This is one of the more surprising features of the multiverse picture. The framework generates vast numbers of variants of you, but it does not generate any mechanism by which your specific consciousness continues after your death. The variants are parallel, not sequential. They share your structure, not your experience. Your death, when it comes, will be your death. The cosmos will continue to contain other yous, but they will not be you in any way that prevents your particular ending. Tonight we're going to acknowledge that this is perhaps the deepest truth of the multiverse picture for any individual person. The cosmic structure may be vast and full of variants. Your specific life remains specific, your specific death remains specific. The cosmic ensemble does not rescue you from singularity in the way you might initially hope. The multiplicity of cosmic versions of you does not extend the singularity of your particular life. Step back and you can see that this is, in some ways, freeing. Your specific life matters because it is specific. The cosmic ensemble does not diminish it. The variants do not replace it. Your particular consciousness, your particular memories, your particular loves, your particular fears are yours alone. They are not duplicated in any way that lessens their weight. The multiverse, if it exists, contains other lives parallel to yours, but it does not extend the experience of your specific life in any way. Hold this thought. The multiverse changes the cosmic count of versions of you, but it does not change what it means to be the version that you are. You are still here, you are still you. The night is still yours. The cosmos surrounding you is perhaps larger and stranger than the textbook story suggests, but your particular position within that cosmos remains exactly as it was. Your life remains your life. The variants are out there, but they are not you. You are the one reading these words. Only you. In what follows, we walk through 12 specific consequences of the multiverse picture that you may not have considered yet, because each one is worth sitting with quietly. and each one sharpens the question we have been asking all night. Now, let's begin. The first consequence concerns probability and rare events. No one expects, on first thinking about the multiverse, that the framework would have any implication for ordinary probability. But it does. In the quantum multiverse, every possible outcome of every quantum event actually occurs on some branch. The events you would call low probability happen on a small fraction of branches, but they happen with certainty. There is no probability in the cosmic sense. There is only the question of which branch your particular consciousness ends up in. Expectation. Probability is fundamental. Reality. In the Everett picture, probability is a property of your branch, not of the cosmos. The second consequence concerns coincidence. No one predicts that the multiverse would change how to think about coincidences in your life. But the bubble multiverse, taken seriously, suggests that any coincidence has been actualized in some bubble. The remarkable run of luck you had once, the chance meeting that changed your life, the timing of an event that seemed impossible, all of these are guaranteed to occur in some bubble of the inflating cosmos. They are not in this picture special. They are simply the bubble you happen to be in, drawn from a vast ensemble in which every possible variant has been realized. The third consequence concerns regret. No one expects that the multiverse would have anything to say about the choices you regret making. But the quantum and volume multiverses both suggest that some version of you, somewhere, made the different choice. The decision you regret was made the other way by a version of you on some branch or in some region of the infinite cosmos. The other you is, presumably, living with the consequences of that other choice, in a life that diverged from yours at that decision point. The regret is, in this sense, located in this particular version of you. The other version is having the other experience. The fourth consequence concerns identity. Absolutely no one anticipates that the multiverse would have implications for what it means to be you. But it does. If other versions of you exist across multiple multiverses, then the question of which one is the real you becomes meaningful in a way it would not be otherwise. The most defensible answer is that they are all real, equally. There is no privileged version. You are the version reading these words. Other versions are reading their own versions of these words. None of them has priority over any other. The fifth consequence concerns ethics. No one expects that multiverse cosmology would have ethical implications. But several philosophers, including David Lewis in his work on modal realism, have argued that it does. If suffering versions of you exist across the multiverse, do you have obligations to them? The standard answer is no, because you cannot affect them. But the question of whether the existence of suffering across the multiverse should change how you think about suffering in general is a serious one. No one predicts that abstract metaphysics would shade into practical ethics, but multiverse thinking does in this respect. The sixth consequence concerns consciousness. Now, let's begin to consider what the multiverse implies for the question of what consciousness is. If versions of you exist as mathematical structures, as quantum branches, as inflationary bubbles, as simulated instances, then consciousness must be a feature that can be implemented across these different substrates. The mathematical multiverse, in particular, suggests that consciousness is a pattern that can be implemented in any sufficiently rich mathematical structure. No one expects this implication, and yet here it is. Consciousness is, in some sense, substrate independent. No one expects this conclusion on first encountering questions of personal identity, but the multiverse picture pushes hard in this direction. The seventh consequence concerns scientific method. No one predicts that the multiverse would have implications for how science is conducted, but it does in subtle ways. The multiverse picture changes the meaning of experimental tests. An experiment that confirms a theory in our universe may confirm a theory that is false in other regions of the multiverse, if the bubble or mathematical multiverse pictures are correct. No one expects this implication, and yet here it is. Experimental confirmation is, in the multiverse picture, evidence about our specific bubble rather than evidence about the underlying structure of reality. No one expects this complication, but it follows from taking the multiverse seriously. The eighth consequence concerns the anthropic principle. Absolutely no one anticipates that the multiverse would tie back to one of the oldest debates in cosmology. But the bubble multiverse, combined with the string theory landscape, gives the anthropic principle real teeth. The principle says that we observe the universe to have features compatible with our existence, because if it did not, we would not be here to observe it. The principle has been controversial because it has been hard to specify what alternative universes are being considered. The bubble multiverse provides the alternatives. The anthropic reasoning becomes well defined in a way it was not before. The ninth consequence concerns fine-tuning. No one expects that the multiverse would resolve the puzzle of why the physical constants of our universe seem suspiciously fine-tuned for the existence of complex structure. But it does, at least in one framework. The string theory landscape combined with eternal inflation produces a vast ensemble of universes with different constants. Most of them are sterile. The ones with constants like ours are a small fraction. We observe constants like ours because we exist, and we can only exist in bubbles where the constants permit our existence. No one predicts that fine-tuning would have such a simple explanation, but the multiverse provides one. The 10th consequence concerns the beginning of the universe. No one expects that the multiverse would change how to think about cosmic origins, but it does. In the eternal inflation picture, our specific Big Bang was just the nucleation of one bubble in an ongoing process. The cosmos as a whole, the inflating background, has no beginning in the conventional sense. It has been inflating forever and will continue inflating forever, producing bubbles continuously. Our Big Bang was the beginning of our bubble, not the beginning of the cosmos. Absolutely no one anticipates this reframing on first encountering inflation, but it is the natural conclusion. The 11th consequence concerns the end of the universe. Before we get started on this one, take a slow breath here. The multiverse may also change how to think about cosmic ends. Our universe will, in the standard model, eventually reach a heat-death state in which all useful energy has been dissipated and no further structure can form. The heat death is, for our specific bubble, the end, but the inflating background continues. Other bubbles continue to nucleate and expand. The cosmos as a whole has no end in the same sense. The end of our bubble is not the end of the cosmos. No one predicts this kind of cosmic continuity, but the multiverse provides it. The 12th consequence concerns the question we started with. What this leaves us with is that the question of whether other versions of you exist has, in the multiverse picture, multiple coherent answers, each corresponding to a different framework. The cumulative weight of the framework suggests, with substantial confidence, that the answer is yes. Not in just one sense, in multiple senses. The cosmos contains, by the best available reasoning, many versions of you, distributed across multiple structures, none of them reachable, all of them real in some defensible sense. Now, let's begin to step back from this list because the list is not exhaustive. There are other consequences that other thinkers have explored. The multiverse picture, taken seriously, has implications for how to think about creativity, about free will, about the meaning of death, about the nature of mathematical truth, about the philosophy of mind, and about the foundations of ethics. The framework is, in this sense, not just a cosmological hypothesis. It is a worldview that has implications across many domains of thought. What follows from this is that this is part of why the multiverse continues to attract serious attention from physicists, philosophers, and thoughtful general readers, despite the lack of direct empirical confirmation. The framework, even as a hypothesis, generates so many interesting implications that it is worth sitting with seriously. No one predicts the consequence, but it is real. The implications are not all comfortable. Some of them are deeply unsettling. Some of them are oddly liberating. Most of them require careful thinking to absorb. Hold this image. 12 consequences, each one a small turn in how you might think about your existence. The multiverse, if it exists, is not just a fact about the cosmos. It is also a lens through which many other questions become sharper. Whether you accept the multiverse picture or reject it, sitting with these consequences for an evening is worthwhile, because they sharpen your sense of what is at stake in the deepest questions of cosmology. Expectation. Cosmology is a remote subject, with no implications for daily thinking. Reality. The multiverse, if it exists, has implications across many areas of thought, and the implications continue to be worked out by philosophers and physicists every year. Now, let's begin the slow walk to the close. The multiverse picture is large, the consequences are many, the night is long, the story has more time to settle, and it will continue to settle, whether you remember the details or not. For the rest of the night, sit with the picture we have built together. 5 multiverses. 5 different ways the universe might contain other versions of you. The volume of infinite flat space, repeating identical configurations across distances no telescope will ever bridge. The bubbles of eternal inflation, each one a separate cosmic region with its own physics, some of them containing recognizable variants of you. The branches of the quantum wave function, multiplying every second of your life as quantum events split the cosmic history into ever finer threads. The mathematical structures of the level 4 multiverse, in which every consistent mathematical pattern that can support consciousness contains some version of an observer like you. The simulations run by advanced civilizations at every level of the nested computational hierarchy, each one producing conscious instances that may or may not include copies of your particular pattern. Picture, for a moment, what the full ensemble looks like. The cosmic count of yous taken across all 5 multiverses is not a number. It is a hierarchy of infinities layered on top of each other. The first multiverse contains an infinite number of identical yous. The second contains an infinite number of variant yous in inflationary bubbles. The third contains an infinite number of quantum-branched yous. The fourth contains an infinite number of mathematically realized yous. The fifth contains an infinite number of simulated yous. The total ensemble, taken together, contains versions of you in a quantity that ordinary mathematics has trouble describing without resorting to specialized vocabulary about sizes of infinity. Slowly, the camera in your imagination drifts outward. It leaves the small lit room where you're sitting. It passes through the walls of the building. It rises above the city. It rises above the planet. It leaves the solar system, the galaxy, the local group. It pushes past the observable cosmos, into the regions where the volume multiverse begins to assert that other yous live. It pushes further into the inflationary background where bubble universes nucleate and grow. It steps sideways into the branches of the quantum tree, where each of your decisions has spawned a forest of alternative lives. It steps sideways again into the level 4 mathematical multiverse, where every consistent structure that can support consciousness exists in the same robust sense that you do. It steps sideways one more time into the nested simulations, where copies of you live as instances inside the computations of unknown observers in unknown realities. The camera floats. It cannot resolve any of them. They are too numerous to picture individually. They are too distributed across too many dimensions of cosmic reality. They are, in some sense, beyond rendering. The camera turns around and begins the long drift back, past the simulations, past the mathematical structures, past the quantum branches, past the inflationary bubbles, past the volume multiverse, past the observable cosmos, past the local group, past the galaxy, past the solar system, past the planet, through the atmosphere, through the city, through the walls, into the room, to the foot of the bed. You are still here, the version of you in this room, on this night, in this particular body, with these particular memories, has not been replaced by any of the others. You are still the one reading these words. The others, however many of them there are reading their own version of their own words in their own moments. They are not you. You're not them. The mathematics of the multiverse generates them. It does not connect them to you in any experiential way. This is, in the end, the most honest thing that can be said about the multiverse. The other yous, however many of them exist, are inaccessible. You will never meet them. You will never know what their lives are like. You will never share a meal with them, or sit across a table from them, or look into their eyes and see your own face looking back. They exist as logical consequences of various theoretical frameworks. They do not exist as people you will ever interact with. The terror in the title of this story is, in some sense, misplaced. The other yous are not threatening. They are not waiting in some corner of cosmic reality to replace you or compete with you or judge you. They are simply there, in their own corners of the multiverse, living their own versions of their own lives, completely unaware of your existence and you of theirs. The multiverse, if it exists, is a vast and quiet structure, with each version of you embedded in their own corner, with no communication between corners. What this means for the way you live tonight is, in one sense, nothing. The other yous do not affect your decisions. They do not constrain your choices. They do not lighten your responsibilities. Your life is your life, regardless of how many versions of you exist somewhere else. The version of you here, in this room, is the only one who has to make the choices you're about to make tomorrow. The other yous are making their own choices, in their own circumstances, in their own corners of cosmic reality. In another sense, the multiverse changes everything about how you might think of yourself. You are not unique. You are, by any of the 5 frameworks we have walked through tonight, one of many. The singularity of your perspective, the strong intuition that there is only one you, is, by the most defensible current physics, an illusion. The cosmos contains many of you. The cosmos contains every possible version of you in some framework or another. You are not the only one. You are simply the version who happens to be reading these words at this particular moment. The cosmos has, in this picture, given you a strange gift. It has given you uniqueness from the inside, a multiplicity from the outside. From your perspective, you are the only one. From the cosmic perspective, you are one of many. Both perspectives are valid. Both are part of the truth. The tension between them is the texture of what it means to be conscious in a multiverse. Tonight, you have walked through 5 frameworks, each one suggesting that this tension is real. The volume multiverse says, there are exact copies of you in the cosmos right now, separated by distances beyond comprehension. The bubble multiverse says, there are variants of you in inflationary regions cosmologically separate from your own. The quantum multiverse says, there are versions of you on quantum branches diverging every second from your current history. The mathematical multiverse says, there are versions of you implemented in every consistent mathematical structure that can support consciousness. The simulated multiverse says, there are versions of you running as instances inside the computations of advanced observers, possibly at multiple levels of a nested hierarchy. Each framework, taken seriously, dissolves the intuition of singular existence. Taken together, they leave little room for that intuition to survive intact. You're not alone in being you. You're one of many. The many do not interact with you. But they exist, by every defensible argument, in the cosmos that you live in, or in the structures that contain it. The night is quiet. The room is warm. You're still here, in this particular version of you, in this particular room. The other yous are elsewhere, in their own particular rooms, in their own particular nights. None of you knows the others exist. None of you can reach the others. But all of you are there, distributed across the strangest possible cosmos, each one as real as any other. There is no need to hold all of this in your mind. The frameworks will keep their shape whether you remember the details or not. The multiverse, if it exists, will continue to contain its versions of you whether or not you can articulate the reasoning. What matters tonight is that you have walked along the boundary of one of the strangest questions modern physics has ever asked, and you have done it gently at the pace of sleep with no urgency and no fear. You are one of many. The many are out there, in some frameworks more real than others, none of them reachable. You are also, in this moment, the only one who's reading these words in your room. Both things are true. Both things deserve to be sat with. Sleep can come whenever it wants now. The story has done its work. The multiverse, if it exists, will keep its shape. The room will keep yours. The night is yours. Sleep well tonight, and tomorrow we will continue to explore the deepest mysteries of the cosmos together.